Hi guys, this video is going to deal with Kirchhoff's voltage law. What is Kirchhoff's voltage law? E, that's the voltage of the power supply, is the voltage drop across the first resistor plus the voltage drop across the second resistor plus the voltage drop across the third resistor, etc. Drawing a simple circuit to show this concept. Why don't we just do something like that with 10 ohms, 20 ohms, and 30 ohms. So 20 volts from the power supply is going to have voltage drops across all the resistors in the circuit. Sorry, let me say that again. The sum of the voltage drops across the 10, the 20, and the 30 ohm resistor are all going to equal 20 volts. So if you have voltage drop 1 across resistor 1, voltage drop 2 across resistor 2, and voltage drop 3 across resistor 3, they're going to equal 20 volts. E in this case is 20 volts. So why don't we figure that out? 20 volts is going to equal V1 plus V2 plus V3. Okay. Do we know V1, V2, and V3 yet? No, not yet, but we can figure it out. Because this is a series circuit, we can add the resistors together to find an equivalent resistance and use that to find the current flowing. So the equivalent resistance in this case, 10 plus 20 plus 30, is 60 ohms. So 60 ohms, 20 volts, that's 2 out of the 3 variables we need. We can plug that into Ohm's law, V over R, 20 over 60, which is 1 over 3, or 33. So the current in this circuit is 0.33 amps. And how does that help us? Well, the current flowing in this series circuit, note series circuit, it's going to be the same across each resistor. So it's going to be 0.33 amps flowing through this resistor, and this resistor. And from that, we can find voltage drop V1, V2, and V3. Check it out. 20, what's V1? Well, V1 equals I1 times R1, right? Just using Ohm's law again. What's I1? Well, it's going to be 0.33. R1, we know is 10. So this is V1. V2, well, 0.33 amps again, because it's a series circuit. Current doesn't change. Going through 20 ohm. And then finally our V3 here, it's going to be 0.33 amps flowing through a 30 ohm resistor. So just grab the calculator here. We're solving for V1 first, 3.3 volts. This is V2, 6.6 volts. And solving for V3 is 9.9 volts. So I'm hoping this comes pretty close 19.8. Pretty close. That's close enough to be good enough. So you can see, using Kirchhoff's voltage law, which is this here, E as the power coming out of the power supply equals the voltage drop across the first resistor plus the voltage drop across the second resistor plus the voltage drop across the third resistor. It's going to be the sum of those three is going to be what's coming out of the power supply. And what we did in this example was solve for V1, V2, and V3 by subbing in the two knowns, the resistance and the current, and getting our V1, V2, and V3, which, taking into consideration a little rounding error, is the sum of those three voltage drops is our original power supply voltage. So that's what I wanted to do for that video, is just deal with Kirchhoff's voltage law for series circuits. As you can see, it's a linear relationship. Like this here, 10, 20, 30, 3.3, 6.6, 9.9. Like they're sort of, as the resistance gets higher, so does the voltage drop. And predictably too. Like if you go from 10 to 20, that's doubling the resistance, and you're doubling the voltage drop. If you go from 10 to 30 ohms, that's 3 times the resistance, and you're going to get 3 times the voltage drop from 3.3 to 9.9. So you can kind of see how that predictable linear relationship might come in handy for solving some unknowns in the future.